This video we're going to review process fundamentals, which is one of the Harvard Business School articles that you were assigned for this class. So remember our definition of operations management. It involves designing, managing, and improving a set of activities that create products and services and deliver them to customers. The basic building block is the process. Processes take inputs and convert them into outputs of greater value. As you've hopefully seen before in one of the other videos, we explained the systems diagram and how the systems diagram is used to really assess the operations environment, and especially to help understand what's going on in terms of adding value through the operations environment. Process analysis deals with a set of concepts and tools that allow you to describe, measure, and improve operating processes. And so it has excellent ties to total quality management philosophy and some of the key concepts you'll study later in Lean Six Sigma management. As an example, let's take a look at a bakery. If we look at a bakery layout, you'll see the different equipment located in different places, from the walk-in cooler with a water chiller, even the office, the restroom, a sink, ovens, proofers, racks, slicers, dividers, molders, tables, flours, starting processors, all organized in a certain way, probably based on the experiences of the owner of the bakery to optimize the ability of the bakers to produce the products that they're supposed to produce on a daily basis. So if we're going to analyze the bakery, where do we start? Well, we start by looking at what products are to be made, what kind of activities that need to take place to make the products, reasons customers purchase from you, what the physical process is like. Let's link the process to the performance of the bakery, and then let's also look at the level of performance required by customers. As an example, if you think about it, if you're a big commercial baker and you're supporting a school system with 30,000 children, you may have to bake at least 30,000 rolls per day just for lunch alone. On the other hand, if you're a small local baker supporting a village where you've got maybe 500 people that are in need of their daily bread, you have to produce maybe 500 loaves of bread each day. So your requirements may be considerably different depending on what it is that you're baking and what the volume is and what the overall requirements are from the customers that you serve. So once we understand the kinds of questions and kind of things that we need to look at, then we can look at the sequence. In other words, how is the bread made? What is the flow of bread making? And in this case, we may map out the process flow of bread making with two parallel baking lines to take into account the different needs that you might have. And you start with inventory, your inputs, and then the processing or the conversion of those inputs takes place through a series of steps like mixing and proofing and baking. Then you may go to another stage where there's a cooling cycle, and again it's treated more like inventory before it's actually packaged and delivered as a finished good. And so, once you understand what the normal sequence is, then you can look at ways in which you might be able to increase the capacity. And it may include altering the flow of items so that it doesn't necessarily move in a sequence that you might normally expect. Instead, you may do things that take advantage of different cycle times, different capacities, different volumes, etc. The main point here, though, is that once you understand how it currently works, then you can look and see what ways can you improve things by restructuring the flow, restructuring the process, if you will, and moving things around. It's not unlike what happens with these days when you've got GPS. If you're caught in a traffic jam, you can often anticipate nowadays where the flow might be constrained, where there might be a real problem with you trying to continue to move steadily. And so you can look for alternative routes in some sophisticated GPSs that point you in the right direction to keep you moving or keep you flowing. And one of the great skills that I've always found useful in my career is, as I started to learn and understand process fundamentals, is the ability to look at things sequentially, understand the flow of products and or services throughout an organization, and anticipate where there might be some bottlenecks, as they're referred to, or places where the flow is constrained or slowed down or even stopped, so that you can then come up with creative solutions to work around those bottlenecks. And creative solutions may mean that you have to move some things around. You may need to add in different kinds of capability. This also will vary depending on the nature of the products that you're developing as well. So again, remember our systems diagram with the inputs and the conversion process, which is where the value add takes place in producing outputs for the market, as well as your management capabilities, and then of course your data and information. Well, inputs generally fall into 4 categories: labor, materials, energy, and capital. And we really want to understand how much of each do we need to make some sort of output. The outputs are goods or services. They typically are finished goods. There are 3 output characteristics: the cost of providing, the quality as defined by the customer, and timeliness defined by the customer. And a question one might want to ask is, can a service be stored, since it's really an on-demand kind of thing? And I would certainly say that the inputs to the service can be stored, but the service is often put together on the spot based on the demand of the marketplace of the customer. So there are tasks that need to be accomplished. It's the addition of an input that makes the product or service more nearly like the desired output. So examples might be operating a drill press to change a piece of metal, inspecting a part to make sure it meets some standard, flying an airplane, or anesthetizing a patient before an operation. Information flows. Some examples include production orders or requests, the number of units to produce, type of units, changes, corrective measures, or stop, electronic transmission, or there's also the sneaker net transmission, which is a non-electronic version. We might refer to it as snail mail, or it might just simply be somebody literally walking from one person's desk to another person's desk to deliver some papers or just simply some information. So how do information flows relate to process flows? Well, generally speaking, they complement or run in parallel, and it helps to understand. And if you have a sophisticated automation capability, even in a bakery, you may have a sophisticated automation system, which is gathering data from all the motors and all the moving parts, if you will, as well as all the temperature controls and other sources of inputs, and is going through to check and see, are there any significant variations, or is everything operating according to the plan? If everything's operating according to the plan, great. If it's not operating according to the plan, there may be alarms or other kinds of visual or audible indicators that suggest that things are not operating as the way they should, and therefore a person needs to take action. So information flows are a very, very critical aspect of any process flow assessment. There's also storage. That inventory, whether it's raw material, work in process, or finished goods, may also need some kind of storage, and so it's important to account for that as well. But as always, it's good, especially when you develop a process orientation, to think of how can we keep things moving so that we're able to convert our inputs that cost us money into outputs that make us money. Because the quicker and the more effective we are at doing that conversion process, then chances are the more effective we are at making a profit, which allows us to sustain our success. Let's also look at how you measure performance of a process. Well, you can look at capacity. In other words, it's the maximum output rate from the process, often measured in units of output per unit of time. So things like 100 rolls per hour, or number of tons per year, or claims processed per hour, or tax returns per day, or patients per shift are examples of measurements. Measured units of output per unit of time. We also, another term that we refer to as efficiency, which is the amount of value of output divided by the amount of value of input. Example, an engine that is 75% efficient can deliver 75% of the input energy as useful output energy. It's also a concept of utilization, input of process used in creating output divided by the amount of input available to use. An example is 100 workers are employed over 8-hour shift producing $700 of labor. Utilization is 87.5%. In other words, they're only working 700 hours even though they're available 800 hours. So they're not 100% utilized. And a question might be, is that a good thing or a bad thing? And you actually, believe it or not, can come up with good responses for both answers. Flexibility is another term we may refer to, and this is a measure of how long it takes to change the process so that it could produce a different output or could use a different set of inputs to produce the same output. And then quality, which we've referred to in other videos. External quality is essentially when you compare the product or service to others or versus an external standard or customer standard. Internal is where you compare individual units with one another or versus the product specification. And measures might include performance, features, reliability, durability, serviceability, and design. Process quality involves process measures. It includes looking at tolerances like scientific or customer. There are some indicators in terms of scrap, rework, yield losses, downtime, additional testing, lost time, goodwill, complaints, including time and money, repair costs. These are all indications of process quality. Process terminology, you may run into terms like cycle time, which is the average time between completion of successive units, bottleneck, the factor or thing that limits production, idle time, time when useful work is not being performed, capacity, how much can be produced or serviced in a specific time period, and capacity utilization, how much is actually produced relative to the overall capacity. Another key concept is takt time, which is the time available to produce a product versus what the customer's demand is for that product. Balance and imbalance refers to, in the case of balance, each step has the same cycle time, there's no variability. In an imbalance situation, there are different cycle times that lead to some idle time or downtime. Throughput refers to the length of time spent in the process. Batch or lot size refers to the number of units of a particular product type that will be produced before beginning production of another product type. Setup time or run time refers to the time spent arranging tools, changing dies, setting machine speeds, etc. in preparation of work on a specific type of product. Runtime refers to the amount of time actually spent manufacturing the item or performing the service. Direct labor content refers to the actual amount of work contained in the product. Management decisions include design choices, ongoing operating decisions, and process improvement decisions. And management complexity involves the variability in outputs, transformation process, outputs, and demand. So again, thank you.